Hello student, welcome to new academic year. So we start our first chapter, Rotational Dynamics. So first of all, what is the rotational dynamics? Dynamics means motion which referring the force is called dynamics. What is the kinematics? Kinematics means which does not referring the force. So it's a difference between kinematics and dynamics. Dynamics means referring a force and kinematics means without referring a force. So what is the rotational? So rotational motion means a motion of the body or object move in a circumference of the circle and it's rotate with its own axis is called the rotational motion or rotational dynamics. So better understanding of rotational dynamics chapter, some points we recall we already learned in 11th standard. So our first recalling point is what is circular motion. Circular motion means a motion of the object of the body which is revolving around the circumference of the circle. So now what is the concept of the center of mass? We'll write the center of mass. Center of mass means a whole mass of the body concentrated on the one point. It's called the center of mass. What are kinematic equations of motion? What are the kinematical equations of motions? We know that the kinematical equations of motion, first, second and third kinematical equations. So which are kinematical equations? So V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2S. And we know that the analogous equations of rotational motions, because velocity is nothing but in rotational motion is denoted by omega. So omega is equal to omega naught plus alpha t. Alpha is the angular acceleration, okay, and here theta is the angular displacement and omega is the angular velocity. So theta is equal to omega naught t plus alpha t square, and next one is omega square is equal to omega naught square plus omega naught square plus 2 alpha theta. Okay, so this is the kinematical equation in translational motion or linear motion. This is the kinematical equations of in rotational motion. And we also learn in 11th standard the real and pseudo forces and their origin and application. So what is the real and pseudo forces? Real forces, which are real forces and which are pseudo force? Real force is centripetal force is real force and centrifugal force is pseudo force. And we know that the examples of real centripetal and centrifugal forces. Okay, so some points we recalling this. Now we see the introductory part of this chapter. Okay, so what is the introductory part of this chapter? First we know that what is the circular motion. Already we learned a definition, and now the characteristics of circular motion. So now characteristics of circular motion means it is an accelerated motion. What is the accelerated? Accelerated means as the direction of the velocity changes at every instant, it is an accelerated motion. And it is a periodic motion. Periodic motion means during the motion the particle repeats its path along the same trajectory. Thus the motion is a periodic motion. Okay, so what is the example of the periodic motion? Periodic motion means motion of the earth, because we repeat its motion. Okay, means 24 hours motion of the earth, day and nights is occur because of its periodic motion. Okay, Now in the introductory part, we see the next point is difference between rotation and revolution. What is the rotation and revolution? Let us see this figure. It's rotation. Rotation means is rotate a body along with a axis. This axis is called a rotational axis. So it's called this motion is called rotation. And what is the revolution? Revolution means is move in a circumference of the circle. So now kinematics of circular motion. What is the kinematics of circular motion? We already learned in 11th standard. Angular displacement means denoted by theta. Angular velocity means omega. Angular acceleration means alpha. Okay, so we get here omega means d theta upon dt, change in displacement with respect to time. Angular acceleration, alpha is equal to change in angular velocity with respect to time. So we get here kinematical equations. It's omega is equal to omega naught plus alpha t. Theta is equal to omega naught t plus alpha half alpha t square, and omega square is equal to omega naught square plus 2 alpha t. So here we know that theta, omega and alpha. This term is analogous with the linear motion. So circular motion and analogous terms with the linear motions. Okay. So relation between linear and angular quantities. So S is the linear displacement. So S is equal to theta into R. Theta is the angular displacement. R is the radial axis, or it's called a radius vector. So R is equal to radius vector. So V is equal to omega into R. Means V is equal to R omega. Is the relation between linear velocity and angular velocity. Alpha t means a tangential acceleration. Alpha t is equal to alpha into R. So A is equal to R alpha. Is the relation between linear acceleration and angular acceleration. And AR is the radial acceleration. So AR is equal to vector of AR is equal to omega vector omega into V omega. V vector, omega vector into V vector. So AR is the radial acceleration, omega is the angular velocity, V is the linear velocity. The relation between linear and angular quantities. Now direction of angular quantities by right hand thumb rule. Okay, so your right hand, if we curve our fingers in the direction of revolution of particle in circular motion, the outstretched thumb gives the direction of angular quantities. So let us see this figure. So here, angular circular motion. Curved finger shows the angular circular motion, and here stretched thumb gives the direction of angular quantities. Means theta, angular displacement, omega, angular velocity, alpha, angular acceleration. It's all in positive terms. Okay. Let us see the second figure. It shows that changing a direction. So here direction is downward direction. So in curved finger shows the circular motion, and stretched thumb gives the angular quantities. So our first point is kinematics of circular motion, and then now second point is uniform and non-uniform circular motion. Okay, so in kinematicals of circular motion we see a angular quantities. Now let us see a uniform circular motion. So uniform circular motion is the speed of the particle remains constant. Means omega and velocity is constant. Means angular velocity and linear velocity become constant. So direction of velocity keeps on changing at any instant. The direction is tangent to its path. So here red lines it shows the tangents path. Okay, so the direction is tangents to the path. Here omega is the angular velocity and then is changing its position. So here A is the particle changing its position, then its direction of the path is tangential. Okay, so tangential part, so the V is equal to 2 pi r upon t is the periodic time, periodic path. So V is equal to 2 pi r upon t. 2 pi r is the circumference of the circle. Okay, so direct distance around a circle is the circumference 2 pi r. T is the time. So this is the motion is called the uniform circular motion. Means without changing its velocity, means speed. Without changing its speed, it's called the uniform circular motion. So for the uniform circular motion, the acceleration responsible for this is the centripetal or radial acceleration, is denoted by AR or AC. So here's means centripetal acceleration. So centripetal acceleration is equal to V square upon R. Means A is equal to omega square R or A is equal to V omega. Okay, so in uniform circular motion, its magnitude is constant. It is given by AC is equal to R omega square is equal to V omega is equal to V square upon R. Okay, so what is the centripetal acceleration? So the acceleration responsible for this motion is along the radius toward the center, called the centripetal acceleration. So why it is called centripetal? Because it is always directed toward the center of the circular motion. So it's called the centripetal. So now non-uniform circular motion. Non-uniform circular motion means your speed is not constant, because uniform circular motion means speed is constant. So it's opposite to the non-uniform circular motion is non-uniform circular motion. The circular motion in which the speed is not constant, means V and omega are not constant, is called non-uniform circular motion. So example for the non-uniform circular motion, so considering the motion of particle on fan when it is switch on or off. Okay, when we switch on, then fan particles gain speed, and then when switch off, then it loses its speed. So move in a circular path. Okay, so the magnitude of centripetal acceleration is also not constant. So we know that AC is equal to, last point of AC is equal to V omega, or AC is equal to V square upon R, or AC is equal to R omega square. This is the relation between centripetal acceleration. So here centripetal magnitude of centripetal acceleration is not constant. The direction of vehicle velocity is tangent to path any instant is increasing or decreasing due to tangential acceleration. Means in non-uniform circular motion, particle gain or lose the speed, or also it increases or decreasing acceleration. Okay, so 2 points here, main points. Whenever in non-uniform circular motion, the speed is not constant, means the particle gain a speed or lose the speed, or and then it increases or decreases tangential acceleration. So here tangential acceleration is denoted by AT. The last point we said the centripetal acceleration is the AC. Now here tangential acceleration denoted by AT. So in non-uniform circular motion, omega is not equal to constant. So alpha is equal to, means angular acceleration is equal to change in angular velocity with respect to time means d omega upon dt, and tangential acceleration denoted by at. So it is equal to r alpha. So when the fan is switched on, omega is increases. Hence alpha is positive. When alpha is positive. When the fan is switched off, omega decreases when alpha is negative. Okay, so alpha means alpha means angular acceleration, and at means tangential acceleration. So here let us see, alpha is angular acceleration, omega is angular velocity. So direction of fan when it's switched on or off. The figure shows the direction of angular acceleration. So here let us see this, alpha is the direction of angular acceleration. Alpha here see direction of, shows the direction of angular acceleration. The positive, this is the negative, and omega is the angular velocity. Now our next point is dynamics of circular motion. So now what is the dynamics? We know that last points we see, this is the kinematics. Kinematics means without considering or referring a forces. Now dynamics of circular motion. So now dynamics of circular motion means motion which referring a forces. So now we are considering two forces, is the centripetal and centrifugal force. So what is the centripetal force? The force which is acting along the radius toward the center is called the centripetal force. Already learned in 11th standard. Okay, so we know that the definition of centripetal force. So all the center seeking force are centripetal in nature. That is, centripetal is the property of the force. Okay, this is not the natural forces, is the characteristics or properties of forces. Okay, so centripetal and centrifugal force is not a real forces or not a natural forces. It means real forces. This is the real force, centripetal force is, but not a natural force. Is the property of force. Okay, so when a body move in a circular path or negotiate a curved path, it requires a center seeking force. So it is denoted by FCP. FCP means centripetal force is equal to mass into acceleration, means AC, where AC means centripetal acceleration. Already learned what is the AC or AT. AT means tangential acceleration, AC means centripetal acceleration. Okay, so now centripetal force is a real force. It exists in inertial frame of reference. So for example, gravitational force, frictional force on vehicle, negotiating curve path, stone tied to string rotated in circular path. Okay, this is the examples of centripetal force. So gravitational force is the natural force, and its natural force, then its property is centripetal. So it's called the centripetal force is called the proper real force. Okay, so let us see magnitude of centripetal force. So Fc is equal to, means centripetal force is equal to mv square upon r. Okay, means here saying this figure, the friction, means centripetal force is the gravitational force. Centripetal force is the here tangential force, and here centripetal force is the frictional force. Okay, is the gravitational force, here tangential force, and here frictional force. So centripetal force is the three types of forces. So Fc is equal to mass into centripetal acceleration. So it's equal to m V square upon R. We know that AC is equal to centripetal acceleration is equal to V square upon R. So put up here AC means centripetal acceleration is equal to mv omega is equal to mr omega square, and FC is equal to next magnitude is MAC is equal to m V square upon R, m into, this is the vector form, this is the magnitude form, this is the vector form of the centripetal force. So m into omega vector cross V vector, because the cross product is equal to minus of m omega square R vector. Okay, so this is the centripetal force in vector form, and this is the centripetal force in magnitude form. So mv square, formula for centripetal force is mv square upon R. Our next point is centrifugal force. The force which is acting on a body performing circular motion along the radius away from the center is called the centrifugal force. We can write the definition. Centrifugal force is not a real force, it's the speed of force. So arises due to centripetal acceleration of the frame. Okay, so centripetal force arises due to frame of reference, and this is arises due to centripetal acceleration of the frame. So consider a person sitting in a merry-go-round. We know that the merry-go-round. So as it starts moving before reaching uniform speed, the person experiences an outward pull. So this is due to the centrifugal force, which is larger than net inward force. So on reaching uniform speed, the centrifugal force is equal to the resultant of all the real forces. That is, in that frame of reference, the centripetal force means the resultant of real forces balances the centrifugal force, all speed of forces. We can write here resultant force is equal to minus m omega square R vector, or m omega square R vector plus summation of all real forces is equal to 0. Okay, because the speed of force. So we get here summation is 0. Okay. So merry-go-round is the example of centripetal force. Another example is dryer of the washing machine, and second another example is in chemistry lab we see a centrifugal machine. Okay, so in centripetal fugal machine, its participants